Remember this lesson, we're talking about increasing and decreasing functions, but really how graphs give us that visual story. All right. So sometimes we write the story, the visual story, and sometimes we get to read it. So in this question here, we are going to be writing the visual story. So a messenger service charges a flat, I think I changed this word to fee on your notes, of $4.95 to deliver a package regardless of the distance to the destination. Okay, so what does that mean? Well, keeping in mind, we're going to pay attention to what our labels are, right? We have distance and we're comparing that to our delivery charge. So if we have traveled, or they have traveled 0 miles, how much are we getting charged? $4.95. So it's going to be like right below the 5 here, right? Okay, so what happens though if we go 10 miles or the delivery company goes 10 miles? Well, they're going to charge us about just under 5, $4.95. Well, what if they go 40 miles? Well, since it says regardless to the distance of the destination, they're going to charge us, see how well I can see here, $4.95. So what would we say about this graph? Okay, because remember, and I'm sorry if that's crooked a little bit just from where I'm looking, remember, we're sketching a graph of the function that models the situation. This we would consider to be a constant function because the slope is 0. It's not going up or down at all as we move from left to right. It doesn't mean that we haven't, or the delivery company hasn't traveled miles. Notice the distance is still increasing, but our charge isn't changing. Okay, so this is what we have what we have here is a constant function. Okay, and it doesn't say to write that stuff, but that's what I just wanted to point out to you. It's not changing. It's not going up or going down. It's staying the same. Okay, now let's compare, not really compare it, but let's look at the next example. At sea level, the air that surrounds us presses down on our bodies 14.4 pounds per square inch, PSI. For every 10 meters, it increases 14.7 PSI. So again, if we want to graph this, if we want to make this our visual story, it says we have the depth below sea level, okay, and the pressure. All right, so it's going to seem a little weird because we're diving, so our depth is increasing, but don't worry about that, okay? Just think of it as in graphing like you used to, right? If we are here at 0, right? That's at sea level. That's sea level. Okay, because as we move, this is us diving down. So at sea level, we're at 14.7 pounds per square inch. Okay, so if this is 0, and let's say 10's about here, 14, about right there. Okay, but every 10 meters, so if I jump over here to 10, it's increasing by 14.7. So if it's increasing 14.7, okay, so, even if you make a little chart here, right? Here's our PSI, and here is our depth. I don't know. That needs to be reversed. I'm sorry. Depth, PSI. Okay, I know it's sloppy, but at our 0 depth, we were at 14.7. Now, every 10 that we go over, so if I'm now at 10 meters, I'm adding another 14.7 on. So if you go 14.7 plus 14.7, that is 29.4. So at 10 here, I'm going to be at 29.4. So if here's 30, it's just going to be just below the 30. Okay? Now if I go to 20, all right, I am going to add another 14.7 on. Well, basically, there'll be 1, 2, 3 of them, right? So I'm going to go 3 times 14.7. Oh, you absolutely could say, 29.4 here plus another 14.7. And that's 44.1. Okay? And again, forgive me as I look at the graph here to do my best guesstimate where these go. So notice that we're just, every 10 meters we go over, we're adding another 14.7, okay? So let's say I jump to 40. Okay. If I did 30, that would be 4 times 14.7. I'm really sorry, this is sloppy. So this is 5 times 14.7. You could have just kept adding it on, it'd be fine. But I want one more point. 73.5. So at 40, we're at 70, right about 73.5. So like right in there. Okay, so now this doesn't look like a great line because it's hard for me looking at my computer screen to do it. But let's try it to the best of our ability here. Okay, so to give us a pretty good line here, and then I will just go make my points. A little bigger, right? Okay, so now what's happening? We can see as our depth is increasing, so is our pressure. That's important, okay? Both are increasing. As our depth is increasing, so is our pressure. Because we always are, as we talk about increasing and decreasing functions, our x values, they're always going to be increasing, okay? All right. Let's switch gears a little bit. So we've been writing our visual story right here, okay? But what if we're given our visual story, okay, our graph, and it looks like this? This is something different. It says the graph below represents the total number of smartphones that are shipped to a retail store over the course of 50 days. So we have A here, okay? So from about 0 to 20 days. That's what's going to be represented by A. And I don't know, not quite 2,500 yet. So there's A, okay? Then we have B. Make B green here, okay? And notice there's that constant, right? Time is still passing, but our number of smartphones isn't going up or down anymore. So that's B. And then we'll have C. I'll put in blue here just so we can see what's going on, okay? All right, so match each part of the graph A, B, and C to its verbal description. Remember, a lot of different ways to show functions, right? Verbal description, equation, table, graph. And then we want to explain the reasoning behind our choice. Okay, so our three options are half the factory workers went on strike and not enough smartphones were produced for normal shipments. Number 2 here, the production schedule was normal and the smartphones were shipped to the retail store at a constant rate. That doesn't mean constant function, it means the rate was constant. And a defective electronic chip was found and the factory had to shut down, so no smartphones were shipped. I'm going to start there because time is still going to be going on, okay? But no smartphones being shipped means things are going to stay the same. So to me, what that tells me is that part right there is going to go with B. Okay? Because notice from here to here, days are moving on, but the number of smartphones is not going up or down. Okay, so I am going to put that right here. This is B, and we have to explain. So we're going to say no phones were shipped. So the total number remains constant. Number of smartphones, but I'll say number remains constant. Doesn't change. Okay, so then we have the other two, right? And both of these the smartphones are being shipped out, right? But in this one, it's at a constant rate. And this one up here, since half the factory workers are on strike, not enough were produced. So I have to think that if I'm looking at these two, this one here is going to be at a greater rate than this one. And greater rate means steeper line. So if I look at A here and I look at C and kind of compare them, A is a steeper line. So I'm going to say A. I'm just going to say it's the normal rate of change. But then, I'm going to add something in there. Got the word of. And I'm going to put steeper slope. Okay, compared to line C. Okay. In line C, smartphones are still being shipped, but the rate of change is less. A lot of times with the stuff we do, we try to really overthink. And there's gonna be a lot of words and graphs, and I know it can be confusing. But remember, those graphs are telling us a story. Really make sure you compare what's the labels on the axes, because that's telling us what our line means. One last thing before I forget. This right here is called a piecewise function. You don't need to know that, except I want you to have heard this term, piecewise. Okay, and all piecewise function means, before I forget here, is that we have different functions on the same graph. There is a function or equation that represents this line, and this line. Okay, so if you see graphs like that, just know that we're breaking it down into those pieces and that a different equation represents each of them.